To get started, to introduce myself, again, I'm Gabby. I'm with NetHope. In case you aren't familiar, NetHope is a consortium of about 60 humanitarian organizations around the world. Specifically within crisis informatics, what we do is we help to work on information and data science related projects within our consortium to improve understanding, to share best practices, and to share important and emerging technologies that are on the horizon. So today we're really excited to extend our platform to Radiant Earth Foundation and hear what they have to share. To introduce our speakers, first let's start with Orlando. Prior to Radiant Earth Foundation, Orlando spent 3 years as a design researcher, policy analyst, and open source software developer focused on global poverty. Working with refugee camps in Haiti and Uganda, Orlando built software intended to improve the livelihoods of those living on less than $1 a day. Before switching to humanitarian work, Orlando was part of the initial team that created the startup Soylent. He has a bachelor's degree in Romance languages and also in journalism from the University of Oregon. Now we're going to hear from Yona. Yona's work is all about leveraging user-centered design for the global development community. Yona helps users by creating tutorials, transforming feedback into platform development, and building geospatial data libraries. He previously served as a technology intern for Radiant Earth Foundation while studying at the George Washington University. He also interned with the social feed manager team at GW Libraries, developing better user experiences with archiving social media data. So next, what I'm going to do is I'm going to turn it over to Yona to kick off this presentation.
Thank you so much for that introduction, Gabby. I'm really excited to be here and connecting with this really powerful community that is trying to really make impacts throughout the world. I'm going to switch over to our slides. I'm going to ask a little patience. I unfortunately have a cold this morning, so I might feel a little bit stuffy, but hopefully I'll be able to get through it just fine. Orlando will be here to really answer any technical questions that we have. He's our geospatial engineer, and so having him to be able to answer some of the really technical, detailed questions is going to be really useful. This afternoon, we are going to look at some of the real applications of Earth imagery. Satellite data for the most part. We'll talk a little bit about drone data, and you can also use aerial imagery. And in particular, we're going to be focusing on how we can use this imagery when we're looking at disasters. And really, when we get to the Q&A, I want it to be a discussion about some of the applications that we can put this into play. A little bit about our organization. Radiant Earth Foundation was founded with the idea that satellite imagery and remote sensing data and processes in general are not very accessible to the developing world and to the global development community in general. So we are looking to connect these communities with the tools and the data that are needed to be able to actually solve some really challenging problems. You'll see the platform that we have worked to develop. That's later on in this webinar. And we also have some projects that are looking at climate change and how communities can be more resilient to it, as well as lots of other health, mining, and agricultural projects that are going on. So without further ado, getting into some of the ideas of where imagery can actually have impact, particularly when looking at disasters. So what you see here is an aerial image that was taken by NOAA and shared of the Gulf Coast right after Hurricane Michael. So you can see some of the erosion impacts that are happening. And And this is just one example of imagery that is actively being collected. And this kind of imagery has been collected for many, many years at this point. Similarly, we have this image, which is a little bit dark, of Volcan De Fuego, which is in Central America, and erupted earlier this year and really wiped out a few villages. And we discussed this actually in an earlier webinar, and you can start to actually see some of the impacts that we can actually get with satellite imagery. Whereas the aerial imagery, which has to be flown with planes and has to be done in advance, rather after the fact, so you don't necessarily have great in advance imagery. Satellite imagery, as we'll talk about later, has the real power of being able to compare before and after. So here's an after shot where you can see some of the lava flows and newly burned areas. And we might actually get to take a look in more depth at this specific example. But the major disaster that I want to talk about this morning is the dam collapse in Bernadino, Brazil. So this was a mining complex that had dammed some areas so as to be able to do some, so as to protect their mines. And because of a lot of safety lapses, one of those mines has collapsed, and there's actually a second one that they're still very worried about. People have already been arrested, I believe, and really the company is being prosecuted by the Brazilian government. But unfortunately, it's meant that many people have already died, and parts of the village have been wiped out. So to give you a sense of what that looks like, so this is a satellite image from the company Digital Globe that was shared publicly. And this gives you a sense of some of the disaster. So most of this brown area is areas that have been wiped out because of that overflowing dam. And so we're going to be able to talk today about how we can use imagery like this, imagery which with the Digital Globe imagery is very finely detailed, but also how we can use some of the imagery that's open and that is always open to be able to actually anticipate disasters as well as respond to them actively.
So just to put in for a second, what Yona is referring to here is, broadly speaking, you could maybe put imagery in two different classifications. You could say you have like public imagery, and some common sources of that would be like Sentinel-2 or Landsat-8, and those are depending on how you get them, freely available, and they're like public services. One is through ESA and one is through NASA. And then there's Yona showing here, this is Digital Globe, it's commercial imagery. It's more of a specified type of image. It's a lot higher resolution and zoomed in, but depending on, sometimes they make things available, but generally speaking, these you'll have to have some kind of agreement with Digital Globe to access. So there's public and private imagery, and open or commercial is what Yona is referring to.
Yeah, thanks for that clarification. And something to note is that this was one image that was made available open by Digital Globe, that they've opened up for disaster responses. And so I'm going to talk a little bit, Alonso mentioned a few things like spatial resolution, that I'm going to help clarify and really make clear what are the different kinds of images that we can actually use in these situations. So within Earth observation or remote sensing, which is the idea of being able to look at imagery and be able to tell things about a situation without having to go on the ground, there are a few different kinds of what are called resolutions. So the one that you're probably most familiar with is spatial resolution. And that's when we're looking at an image, which is made up of pixels that are captured of the different there are pixels that are captured with the light that's going on. And this is the same thing that happens on your phone camera, for example. You can get different spatial resolutions, which is what's the size of the thing that you're able to actually see and make out. So on the top row, these are all open imagery from NASA and from the European Space Agency that have what are a little bit coarser resolution. So at the top left, the MODIS imagery, which has 250-meter resolution, which has been around since the early 2000s. That's a NASA satellite. The Landsat 8 satellite, which has been, Landsat 8 is only a few years old, but the Landsat program, which has had 30-meter resolution since the 70s. And then Sentinel 2, which are two satellites that work together to have 10-meter resolution, and that's been available since about 2015. And on the bottom row, you have Planet Scope, which is 3-meter resolution, Pleiades, which is by Airbus, which has 0.5-meter resolution, and Worldview 4, which is 0.3-meter resolution. And a quick note, Worldview 4, unfortunately, earlier this month, lost its gyroscope and so is no longer able to provide imagery. But Digital Globe, which owns the Worldview series, still has Worldview 3, so that they're able to still get some imagery. The second type of resolution that we talk about is temporal resolution. And that's the idea of how often can we get imagery of the same location. So in many cases, we're talking about global cover. In a few of these places, it's just how often can we get to a single place, but not necessarily taking of the entire Earth. So the MODIS imagery, that's that really coarse grain, 250-meter, takes that every single day. And there are two satellites that do that in the afternoon and evening, in the afternoon and morning, rather. And that helps to make sure that we have full cover of the entire world, and especially looking at climate data as well as agricultural data, that can be really, really powerful for. Planet Scope, which is basically a constellation of 100 or more than 100 very small CubeSats that is used by the Planet company to make sure that they can get imagery at 3 meters every single day. Now that is commercial imagery, so it does typically cost money, although they do open up some of their imagery in the cases of disasters. But that is every single day. Worldview 4 and Pleiades by Digital Globe and Airbus are able to have revisit times at a fairly high rate, but that is more on request. So they don't cover the entire world every single day. Instead, that they take imagery when it's requested. Sentinel 2 by ESA has 5-day temporal resolution, which they get by moving two satellites in opposition to each other. And they're able to cover the entire world every 5 days. And Landsat 8 takes images at 30 meters every 16 days. There's also a Landsat 7 satellite that is flying, but its imagery has some issues. And with that Landsat 7 imagery, you can get a little bit of a higher temporal resolution. The last resolution I'm going to talk about is spectral resolution. So typically when we take a photograph with our camera, we might think of it as we're taking a color photograph. It's just light that it's being captured. In reality, your camera is actually taking 3 different photographs. One photograph is taking of red light, one photograph of green light and one photograph of blue light, and then they layer those images together in order to actually make the color image that you're used to. There's a lot more to the electromagnetic spectrum than just visible light, and we can actually learn a lot about the world by being able to see those different parts. And that's where some of these satellites really come into play, is that they're able to show more of those typically invisible parts of the spectrum. So just a few examples of what this looks like. So this is a graph of what that would look like along that spectrum of light. You have to flip it a little bit because this is red and this is blue. So ultraviolet, the 1 is red and the 3 is blue. So ultraviolet would be to the left and infrared would be to the right. I think I may have misspoke that it's 1 is blue and 3 is red. Just make sure that that's clear. And as you can see, there's a lot of information that we can get from the infrared part of the spectrum. So if you're looking at water, which is in blue at the bottom, you can see that it's somewhat visible, but pretty dark. It reflects light fairly, it reflects only a little bit of light in the visible spectrum. But once you get to the infrared spectrum, it's completely absorbing all of the light. Vegetation, which you'll notice is when you get to the band 2, is a little bit greener in the visible spectrum. When you get to the near infrared part of the spectrum, it gets really, really high reflection. And so while we usually think of plants as green, in reality, they're near infrared. And that can actually be used to be able to really tell the difference between vegetation and water, because within the visible range, they can look kind of similar. They're both fairly dark. But in the near infrared range, they're actually really, really bright. Soil, similarly, is a little bit brighter visibly, but then when you get to, it is about mid-range with near infrared, but when you get to intermediate infrared, which is also known as shortwave infrared or SWIR, is much, much brighter of a reflection. And so we can actually use these different, what are called spectral signatures, these little graphs, to be able to tell what something is. And you can even tell the difference between different kinds of vegetation. And that can be really useful, although being able to tell the difference between, say, different kinds of vegetation is a little harder. Being able to tell the difference between vegetation and, for example, iron-filled water that is flowing over a dam is a little bit easier when you're able to use some of these different parts of the spectrum.
And one of the really powerful thing we can do here is, and Yona might discuss this further on, but we can combine this in a temporal fashion. And so you can imagine if you're trying to, if you have some plants that maybe their spectral signatures are a little bit similar, and it would be hard algorithmically to differentiate them just from one snapshot. If you look at them over the course of an entire year, you might see a bigger change, right? You might see, oh, in one, there was a bloom in May, and this other thing was obviously harvested or something like that. Suddenly the spectral signature just completely changed. And so, you know, as we stack things into layers and analyze them temporally, you can get a lot more detailed information about what you're looking at.
Yeah, exactly. So just to give you a sense of what those different spectral resolutions look like on different satellites. So here are the some of the open satellites that are available. So you'll see here that Landsat 7, which I mentioned earlier, has the visible as well as the near IR and the shortwave infrared. There's also the thermal infrared that's available that can tell information, especially about things like soil moisture that can be used for that. And then Sentinel 2 has very similar bands. It has more granularity when it comes to near infrared. So if you look at that visible near infrared, so that's called red edge, and is and that can be really useful in telling the difference between different kinds of vegetation. And they don't have the thermal infrared. The other satellites that we have that we were talking about, so Planet, the PlanetScope data has just visible and near infrared, so just 4 bands of light that it captures. Airbus and Digital Globe, as well as MODIS, have the ability to capture, yes, the typical visible and near infrared, but they also take multispectral images so that they cover a much wider range. Instead of just little selections, they cover a much wider range of the light spectrum. So now that we've talked about these different kinds of resolutions and kind of started to get a sense of what kind of different imagery there is, we can actually get into looking at it and using our platform to be able to actually do that. So if you want to follow along, you can. Otherwise, there is this will be available as a video. You can go to app.radiant.earth, and that is where our platform is. If you look at the right where it says doc.radiant.earth, that gives more information about the API that's available. And you can bring that up as a question later. But for right now, we're going to focus on the platform. So I am switching over. There we go. So this is the login screen. You can log in with any of these social accounts, or you can just typically sign up. But for right now, sign in. So this is the home screen. And as you can see, there's at the top, there's really emphasis on projects and imports. And so we're going to really dive into projects. You'll also notice that you can analyze, and we'll talk about that a little bit later. So we're going to just start by looking at projects. So with our platform, a project is the basic unit of analysis, kind of like a layer. And you can put together multiple images within one project. But for the most part, you're going to want to keep it to one date. So that you would, for example, looking at this image of the campfire in Paradise, California, where we put together 2 images and what's called mosaic them together. But this is just from one single date. And so we're able to use this. You'll notice that it looks a little funky, and we'll talk about that in a minute. But we're going to go back to projects. And we're going to create a new project because we specifically want to be able to look at what's going on in Bernadino. So we're going to create that new project. We're going to call it Bernadino Dam Disaster. We're going to choose a standard project. An area of interest project can be used where it will automatically bring in imagery that matches a specific filter. But if you're looking for things that have happened in the past, we're going to use a standard project. And we're going to search for available imagery. And here you can see the map that we are at. And as you sort of pan around, you'll notice that all of these, that in the left where we're browsing scenes, it's updating automatically. And that is bringing things in live. And you'll notice that some of these are as recent as January 30th. Sometimes you'll even get, here we go, from January 31st. So that you'll notice that imagery is updated really, really quickly in here and pretty much live. So we're going to search for Bernadino, Brazil. And this is sort of the area. And you'll notice that it's a map and not a different, and not sort of a satellite image. While you can bring up some of the satellite imagery through different layers, individual scenes are basically like different photographs that you would layer in. To search for imagery, search for different imagery, you would want to use filters / repository. So repository is where the imagery is available from. So Sentinel 2 and Landsat 8 imagery is available through Radiant Earth platform. NASA CMR is where Landsat 7 and MODIS imagery is. And Planet Labs, so if you have an API key, especially to use open imagery, or if you're able to get some imagery from them or are able to pay for it, you would be able to connect your API key in the account settings and be able to actually look for planet imagery within the platform. For right now, we're going to stay in the Radiant Earth platform. And we're going to look at Sentinel 2 imagery. You can set the date, but it shows the most recent, and we're looking for really very recent. And then area of interest. So in advance, I made a little polygon, which you can either draw or you can import a shapefile, which is a little geographic boundary file. And that just shows exactly where it is. And it'll filter imagery to exactly within that little area. You can also filter for cloud cover. While you often want to be able to find cloud-free imagery, in some cases, clouds are going to be in the image no matter what. And if you want the most recent imagery, even though that much of the image that you want, like the one that we're going to add, has a lot of cloud cover, the area that you want to really look at does not. So we're going to just add it. You'll notice that there's a little blue icon here. That means that it's cloud optimized, which means that it's already loaded into our system and anyone can use it already. If it has a gray icon, that means that it hasn't yet been turned into a cloud optimized file. So it'll take some time in order for it to load. Once it's loaded, it'll be available for everyone. You can close that out. And you'll notice that it's very dark, and that's partly because there's so much cloud cover. Because the platform automatically stretches the pixels that it is visualizing to the minimum and maximum. When you have high cloud cover, the maximum is very bright because of the white clouds. But that means that some of the things on the ground aren't as visible. One of the best ways to be able to look at this in other ways is by looking at some of these color modes. So we have to, in order to activate all the different color modes, we have to refresh. But these different color modes are ways of layering those different spectra that we talked about earlier. So for example, the normal visualization that we're used to is natural color, red, green, and blue layered on top of each other. But a very typical one that we might use is infrared. So you can't see it as well here. So I'm just going to switch out quickly to look at this volcano one. And looking at color infrared, what that looks like. You'll notice that all of the vegetation, so this is what it looks like in natural color. Everything's kind of dim, but when you use color infrared, where you're displaying any near infrared light as red, any red light as green, and any green light as blue, you can really, really tell where all of the vegetation is. And when you look at an urban area, for example, you can really see where some of the vegetation is. So we're going to go back to here, and you'll notice that switching between these is really, really fast. Displaying things, because everything's running on the fly and on the cloud, none of this is having to take a toll on your computer. So we're going to go back to color mode, and we're going to actually use the shortwave infrared. So that's where shortwave infrared light is shown as red, near infrared light is shown as green, and I believe in this case, red light is shown as blue. So here you can actually make things out a little bit better. We're going to use that area of interest just to help us find the area a little bit easier. There we go. And so here you'll see some of where it's happened. So if you remember earlier, when we were looking, so here you'll see that there's a lot of sludge that has flown from this dam. And we'll be able to see this in a little bit finer detail when we look at older imagery. But you can sort of see this little river that is going across. That's the normal route of the water, but instead this much darker area is where some of that sludge has passed. So remembering that the green is vegetation, and then anything that's red or brown, particularly red, is soil that's reflecting really, really well in the shortwave infrared. Just a few other quick features to run through. You can add annotations, so you might want to sort of map out the extent of the spill, which you can then also export as a shapefile or a GeoJSON. You can export the actual imagery. You can publish it to a public page where you would just be able to share this with people so that they would be able to see your map. Or you can also share it with individuals. So I'll show you some imagery that was shared with me or with this account. You can also share with organizations, which are all managed in account settings. So you would be able to share with your team, this is the imagery that's available. I'm going to close that for now. But we're going to hop right into some of the analytic capabilities and show you what we can actually do. So we would go to the lab, and you start with a template. So this is only available right now for raster algebra, which basically is taking the values of the different bands, the different spectra, and taking what that value is and adding or subtracting or dividing it in order to match certain indices. So we might be able to say for example, compare red light that was reflected in an older image with red light that's reflected in a newer image and see where things have changed. And you'll see where this is really useful. So we're going to use we're actually going to use a normalized burn ratio change detection. So even though that this isn't burn, normalized burn change detection, if we look at this template, it uses near infrared light and shortwave infrared light. And because we're looking at a difference between the type of sludge that is highly reflective in shortwave infrared versus the type of versus the near infrared light, which reflects vegetation really well, we're able to get a sense of exactly where this is going and what this is affecting. This is normalized a little bit so that it's on a scale rather than, so that each of these is on a scale rather than from 1 to -1, because as you notice that was a very dark image, and the other image that we're going to use is a little lighter. So we're going to just call this Bernadino change. We're going to create the analysis. And here, then you can select a project. So for the older one, I'm going to use an image that was shared with me, which I believe is this one. And we're going to use the near infrared. And then, again, the one that was shared with me, the shortwave infrared. And that was from an older image from January 17th. That was before the dam collapsed. And then we're going to be able to do the same thing with the image that we already selected, the near infrared and the shortwave infrared. And this is clicking that little map icon, we're able to see some of those differences. So we're going to zoom in, and I believe that it should be right here. So here you'll see, you can still make out some of the differences, but in the bright area, this is really showing where shortwave infrared light has gotten a lot brighter and near infrared light has gotten a lot darker, which in this case means that there is more reflective soil and less reflective vegetation. And you can actually do this really cool thing. If you'll click this little slider button, you can take the difference between these two and actually see exactly what it looks like before and after. So on the left, you have what it looked like prior to this dam collapse. And after, you can really tell where the sludge has come out of the dam and flown through and actually hit this river. And you can even see some of the village areas that have been affected. So if you notice right here in this sort of at the where it turns, that there were some fields and villages that had been occupied. Those little patterns of rectangles are usually fields that have been flooded by this river of sludge, basically. There's lots of other things that you can look at. One of the main things is, I'm going to go through this very quickly. One of the main things is being able to tell the difference with fires, or in this case, lava. So here you can really tell the difference. Here we've actually used this histogram tool to be able to really identify where that main change has been. You can also take that off to see where that difference has occurred. And this is where the volcano had taken down certain areas. So we have some time left. At this point, gonna turn it over to questions with one quick digression to mention the fact that you can import your own imagery. So you would go to data and import scenes. So you can import drone imagery, or if you buy other satellite imagery, you can bring that in, or aerial imagery, and that can all live on the platform. So we are now going to turn over to questions.
Wonderful. Thank you, Yona and Orlando. This has been really incredible to see. There's a lot of work that's been done on the platform. And so let's dive into some specific questions. And again, to those that are listening in, please plop your questions in the chat window, and we'll speak them aloud to Yona and Orlando. So going to Benson's question, have you been able to leverage LiDAR or other sources for terrain and 3D modeling?
Orlando, do you want to take that one?
At this time, we do not have any digital elevation maps on the platform, but we are working towards incorporating some of those different types of data sources. But right now, we don't have, we don't have those.
Great. Another question that was asked, and a lot of you talked to this a little bit in the chat window, but I thought it'd be good to vocalize it. Does the Radiant Earth platform cover all areas of the globe?
Yeah,
I can take that one. So the platform has imagery that covers the entire globe, so that so the MODIS imagery, the Sentinel imagery, and the Landsat imagery are all global cover. So basically they have an orbit that specifically takes them around to cover the entire Earth. And that happens in the case of Sentinel-2 every 5 days, Landsat 8 every 16 days, and Lotus every single day. So that is the entire Earth, and you can see all of it through the platform. All of that imagery is available.
Great. So we have a question
on your, if you're trying to look at certain things in the ocean, different sensors, these are satellites, and so they're often charging when they're going over water. And so in some areas, if you're really interested in actually getting data of just the ocean and does not land, like Sentinel, I think provides a pretty limited coverage of actual ocean area. But in terms of land cover, it should be global. And I think I'd have to check on the exact coverage of polar regions because that would depend on the orbit. But like Yona said, most areas are covered.
Great. We have a question from Marielle, and they ask, where/how would be the best way to learn about image processing? Seems like the platform can take care of applying transformations, but a user would need to know how to combine them.
Yeah, so the platform does not at the moment have a lot of image pre-processing available. Some of the limitations of making it as fast and as cloud optimized as possible.
What types of image processing is that person asking about?
Marielle, I would say if you have any specific imagery that you're speaking to, drop it in the chat window, and Alonda and Yona will speak to that specifically.
Yeah, so we do have a list of guides kind of for getting started with how to do, when Yona was going over some of these labs, these different analyses, we have some guides to show like how to do that and what applies for what. And I pasted a link for that, but I'll paste it again. The types of image processing that's available right now is going to be mostly bandmath processing. So like NVR or NDVI or these other things, you're doing some kind of algebra on the different spectral bands of each satellite. That's all supported right now. Something that is in development, is not currently available on the platform, is doing more complex, applying more like advanced machine learning algorithms to these. And right now that's not supported, but we are working on incorporating those in the future.
Great, and building on that, earlier question that we got was, in order to use the Radiant Earth platform effectively, what kind of technical skill or spatial understanding is needed?
That's a great question. The platform as it's designed is hopefully aiming at some of the lowest skill levels that are available. We really want to be able to give a lot of access, as much access as possible. As you could see throughout the demonstration, it's if you are familiar enough with the internet and how buttons work, it's fairly straightforward to actually use it. There is a little bit of a learning curve in terms of knowing exactly what you're looking at, and it takes a lot of practice. So one of our goals with doing webinars like this is to help people understand, what are the different resolutions, what are the different spectra that you can actually look at. And it's something that's definitely a work in progress. I'm still learning some of this too, and there's a lot of really active research as to how to make it all possible. But it's something that from the basic level is, basic level of being able to look at things is accessible to anyone. Being able to tell things, what's going on in a scientific way takes a lot more training.
Another resource that is available for our users is us. And we as an organization, we have this platform, but we also want to be a knowledge base for folks who have questions about their specific use case. And that's why we have hello at Radiant Earth, and you can reach out to us on social media if you have questions about how to do something or how to perform a particular type of analysis, we want to engage with you because we think that probably other people also have that same question. And so when we have, again, like as I posted there, we have a, sorry, I sent it on a private message. Let me post it again publicly. Let's see, all attendees, all participants, here we go. We have a series of guides that we want to make it as easy as possible for somebody who just has a question about a use case in their area. I want to know in my area what happens with this fire. I want to understand how crops have changed. I want to understand something else. And we have guides that are trying to take you from that question to performing an analysis. But additionally, if that it doesn't answer it all for you, or you have some other questions as well, we want you to reach out to us, and we want to help you use our platform and use this available imagery to get the answer that you're looking for. So we are a resource as well in addition to the platform.
Yeah. In addition to the help site, which is help.radiant.earth, the two best ways of reaching out to us in the community. So the first is there's a Facebook user group, which is designed for people to be able to have conversations about what the projects that they're working on and get help from their peers. But there's also on the site, there is a little chat button at the bottom right, a little blue chat button that notifies me, and please feel free. I really enjoy having those conversations with users and helping them. So that's a great way to get in touch with us and to tell us what you're working on. If there's something that you get excited about, please share it. And if you need any help, we're here for you.
Yeah. Every day we get emails from users who have a specific use case or something else that they want to dive deeper on, and we love interacting with our users and trying to find ways to help them solve problems. So.
Wonderful. So to that point, we're going to wrap up very soon, but this leads into the next best question. And again, if anyone listening in has any more questions, please plop them down, and we will give Yona and Orlando a chance to answer them. So what kind of users is Radiant Earth Foundation hoping to bring to the platform? Who's using it now, and who do you hope to have use it in the future?
That's a great question. So we are aiming particularly at members of the global development community. The platform is totally open, so really anyone can use it. We have a lot of members of the academic community that have been using the platform, but it's particularly designed for people who are helping to provide answers and solutions to people working in the field. So that often will be people who have some specialty within the area, within their specific area, with knowing remote sensing imagery. But we want it to be open to everyone.
Yeah, we have a wide constituency of users ranging from academics and researchers who are basically using our platform or our API as like a data faucet, to users for nonprofits in various countries around the world, to NGOs. We actually have a couple ongoing projects with the UN, and so it spans the whole gambit. And we try to make our platform and also our knowledge base available for folks everywhere is our goal.
Great. And to confirm, Yona and Orlando, the platform is no cost, correct?
Yes.
Wonderful. Wonderful. Well, we're going to wrap up here. Thank you so much again to Orlando and to Yona and to Radiant Earth Foundation for, one, creating what you've created, offering it as you have, and also taking time this morning to walk through it for all of us. Thank you to everyone who's listened in for your great questions. To remind you that there will be a poll when you close out of the meeting. We'd love to get your feedback. Also, for your colleagues that weren't able to join in, there is, you'll be getting a link soon, so you can pass it on to anyone in your organization that might be interested. Of course, if you want to learn more about Radiant Earth and to get into the platform, please visit radiant.earth. We'll also include that in our follow-up email. And then also thank you so much to NetHope Solutions Solutions Center team for helping to host, manage, produce this webinar. It's been great to hear from everyone. I wish you all a great day, and we'll be in touch soon.
Thank you.
Thank you, everyone.